Hi guys, I hope you do well. I hope you are all well in these hot summer days, at least here in Middle Europe, in Austria, Vienna. It's quite difficult to make a video with these high temperatures without an air condition. I have only a fan. For this reason, I'm making a little bit more a fan video. And with these high temperatures, we will do, of course, high voltage. What else? Yeah, but not really something, I should say, extremely technical. This video will show you, some small modules that I treat as a toy. Yeah, but it's a toy that can give you a really punch. Anyway, some times ago, many moons ago, I bought a few modules from AliExpress, like that are sold as high voltage drivers, generators. You see, I broke this one because it had this doubler attached, and I will use this doubler for the other module too. Anyway, I took two different ones. This one that looks a little bit crusty, a little bit old-fashioned with this transformer. I will show you, of course, the completely reverse engineered design, the schematic. So this is the first one. Anyway, black PCBs. I love black PCBs when I do my designs, but they're awful for troubleshooting or for reverse engineering. Anyway, that's the one thing. That's the one. It uses the 70H04 6-time inverter as a driver chip for the low MOSFET, and to drive the transformer for the high MOSFET. Anyway, you will see it on the schematic. And a few other interesting things, how this thing works. So that's the second one. That's a little bit more modern because it doesn't use any transformer or anything. It uses a dedicated gate driver chip. Otherwise, the design is more or less the same. Yeah. So, and all of them can drive directly a coil. Could be this one, this high voltage coil, or something else. But these things are sold as a high voltage driver. So this is why I'm using this coil to show you. This thing can produce, I think, 20 kilovolts or 15 kilovolts. I'm not sure. As I said, it's a toy. These are used to generate ozone for cleaning the air in air conditioned systems. Yeah, they are very cheap. You can find these things. Of course, not the AC version. This thing should be rectified so you can have an ozone generated. Anyway, these are very cheap. You find it everywhere in different sizes, shapes, and output voltages on AliExpress and eBay. As you can see, I already had done some tests with this thing. Yeah. So this is the high voltage transformer, primary, secondary. You see the primary is on the inner side around the core, and the big winding, or this slotted windings here, is the secondary itself, yeah? Completely potted. So, and we have here the same thing, but with a doubler. But don't let this thing fool you. This thing can give a punch. Look. It uses a 1 nano 20 kilovolt capacitor and the 100 pico. The 100 pico is not the problem, the big problem. This big Bertha here is a problem. It will not do you anything, harm you really, but if you touch it, it will give you a punch that will make you swear everything that you know. Yeah. Anyway, you will see what I mean. So, this is what we will see today. As I said, this is more as a fun video, playing a little bit with high voltage and to show you how these things work, because they are not bad. Both of them are in a half bridge configuration, DC-DC converters, drivers, and for that what they cost, they can be used in a few things. Yeah, honestly, I can imagine this thing in combination with that and perhaps a second stage in a stun gun. Yeah, you will see it. It puts a lot of power in the output, and power that hurts. Yeah, look. But this is what I mean. Yeah, this is what happens when you are not careful. Anyway, it smells, burnt flesh, but it's okay. I'm used to it. I'm used to that from the old CRT TVs here. If you forgot to put some gloves or something, then you had these things. It doesn't do anything. It just burns you a little bit. Yeah. Anyway, so for now, let's take a look on the schematic. So let's take the first one, the first module. This one. Yeah. You see, wow, what a zoom. Yeah. This is the more crusty one, the more older one that uses as a driver chip, yeah, for driving a 70H 74HC104. That's a six times an inverter, where 3 and 3 inverter gates are parallel together to drive the transformer and the low MOSFET. Yeah, let me show you how the schematic looks on that. Yeah, the problem with these things is, of course, black PCB. It's nice, they look good, but they're awful for reverse engineering. Yeah. Anyway, so let's take the schematic. Starting with the left side, of course, left to right, we have a 7805. This one. Very crude, just with two capacitors, nothing else, and they specified up to 24 volts. And you know that the 7005 is the maximum voltage, is 24 volts. Yeah? So this thing is getting warm. Anyway, the 5 volts are for the generator chip, and here we have the first interesting wobble. The first interesting design. They're using a microcontroller, an STC 15W101. It's an 8-pin microcontroller, extremely cheap, of course. Yeah, but in the beginning I thought, okay, it's an 8-pin, that's a 555. No, it's not a 555, it's a microcontroller, and it's not a static frequency that is generated here. It's a sweep. They're sweeping, I don't know exactly, I didn't measure it. You will see it on the scope later, but I didn't measure it exactly. It goes up to 200 kilohertz or 150 kilohertz and down to 50 kilohertz or something. So they're sweeping quite a broad range of frequencies. Anyway, here we have the 74 inverter, 6-time inverter chip. We have 3 and 3 gates parallel together. To drive the transformer itself, the gate transformer, this one. This is used for the high MOSFET of the half bridge. And the other 3 ones are connected again to the transformer and drive the low MOSFET of the half bridge. These are the MOSFETs of the half bridge, high and low. And then we have here the 2 capacitors of the half bridge. It's just 1 microfarad ceramic capacitors, but they deliver quite a power. You will see. These are the 2 capacitors. So this is how it looks. This is the first module. microcontroller, driver chip, driver transformer for the high MOSFET, and part of the driver chip, the 74 chip for the low MOSFET. And here, in the middle of the totem pole of the MOSFETs and the half connection of the two capacitors, comes the coil. And the coil can be either one coil with an rectification and doubling or multiplying, or just a standard coil for AC. So this is the first one. The second one is a little bit more modern. This is the second one. Let me show you near again. You have here this 74, the regulator itself. You will see on the schematic that there is, I don't know why they did it. They write 7812, that I would understand, yeah. But they put a 7805, and on the PCB you have again an SMD 78L05, and they are cascaded in series, so it doesn't make a sense. I don't know, either they made a mistake and instead of an 7812 they used a 7805, or I don't know. Anyway, again, the driver chip, the generator chip, is again an STC microcontroller, a different one, but a microcontroller. But the major difference on this half-bridge board, again, PCB board, module, however you want to call it, is that they are using a half-bridge driver chip, a dedicated one from EG Micro. I like EG Micro, I use them a lot because they are cheap, and they have a lot of clones from the IR parts, international rectifier parts, but much more cheaper. You can get it on LCSC, for example. Yeah, you will see this an EG Micro device probably in my one or two of my future videos. I'm not saying what, but you will see. Anyway, and here the difference is that we have the half bridge, the divider capacitors as SMD. I like this board more. It's more modern. It's not a big difference. And again, we have the RFZ44N, typical transistor that he used from Chinese boards everywhere. Yeah. Okay, let's have a look on the schematic. So we have here the TO220 regulator that should be an 7812 that generates the voltage for the chip itself, for the gate driver, for the half-bridge driver chip itself. But it's a 7805, so okay. And then you have cascaded after that a 78L05 just for the microcontroller. And this time the microcontroller is an STC, let me read it better, STC 8G1K08. That's a mouthful, huh? Anyway. And again, here we do not have a static frequency. It's again a sweep from 2. I will show you an example on the scope in a jiffy. And here you have the EG Micro EG3013S half-bridge driver chip that generates the voltage for the high MOSFET and can drive the low MOSFET too. Yeah? And you have here the two capacitors that generates the divider. This time there are 2.2 microfarads. Additional to that, we have this transformer and driver board here. And this is the schematic of it. Normally, if it would be flipped around, and or this one, the capacitor would be on another side, would be a normal configuration, but this is how they did it. Here you see you have 100 pico directly connected to the transformer, the two high voltage diodes that are 2CL72, that are 10 kilovolts each, 5 milliamps, and the output, more or less, capacitor, that it's a 1 nano 20 kilovolts. This is quite a punchy thing. Yeah? Do not underestimate this thing. This hurts. So this is how it looks, and I'll show you again. I hope we can see it. Yeah, I have to be a little bit careful of that. You see that the high voltage diodes have one ring that it is uninterrupted and one ring that it is dots around that. And this is the coding of these diodes. It is easy to find it. These are 2CL72 here. And the two capacitors. They are quite nice, powerful. And this one hurts. So, this is what I wanted to show you. Yeah, this thing is crap. Because if you space these two electrodes a little bit more apart, the problem is that here you have immediately an arc over. Very bad construction. Anyway, this is not something that I say, yeah, wow, good. I just wanted to show you how this thing looks and how this thing works. As I said, this is a fun video, and I'm not expecting that this will be used much anywhere, yeah, except of a stun gun, perhaps, yeah, or I don't know, just to play like I do. Yep. So let's have a look a little bit. Let's scope it a little bit, and after that, let's see it in action. Let's see what the scope says, what this little module here produces. You will see that it isn't a static frequency, it is a sweep from a lower to a higher frequency. Let's take a look. So, this is what we see. It's interesting that they are doing a sweep. I expect the static frequency, but this explains why they use a microcontroller instead of, I don't know, a 555 timer or something. So this is how it looks. I think it goes up to 200 kilohertz and down to 80 or something, or 70. It's too complicated for me with this equipment to measure it, what I have. And that's the second module. And we will check the output frequency of the microcontroller of this module too. But spoiler alert, yeah, it will be again a sweeping. So let's have a look. And again, it's a sweeping. This one is a little bit a higher frequency, and the range goes not that low as with the other module. Yeah, but again, it's a sweep. Good, and now we will see what the impact of these modules is. Let's have a look. So, this is the module with the gate transformer and the 70HC04 as a driver chip, just connected directly to the transformer itself, the high voltage transformer. We have 24 volts. Look what it's capable of. Rather high frequency. And we'll check the same module with the multiplier. So I connected now the multiplier instead of the transformer alone itself. And guys, if you're wearing headsets, low the volume. I'm warning you. You will see what I mean. Look at that. 24 volts again. Wow. Let's do it again. And a little closer. I like it. Sorry, but I like it. In reality, this looks much more impressive than on cam. Okay, let's check the second module now. The one that has just the driver chip without a gate drive transformer. 24 volts. This is much more powerful. I have to blow it out because it's a really nice arc. A certain distance, you see? Ooh, nice warm arcs. Yeah, well, let's check now what this thing does with a multiplier, because that's what we see here, wing, 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 is just AC. So, now the module with a dedicated gate drive integrated circuit connected to the multiplier. It's just a doubler. It's not a real multiplier. It's the transformer and the doubler and behind of that, yeah? Anyway, again, lower the volume of your headphones if you have any. Now let me see, let us see what this thing does. 24 volts again. And of course, these capacitors have to be discharged. This thing is fully charged at the moment at almost 10 kilovolt. That gives a punch, yeah? As I showed you before, it's quite a big one, yeah? So guys, don't want to make this video unnecessarily long. As I said, it's a fun video. The lighting is, of course, again a problem. Anyway, yeah. I hope you like my videos. I hope you like the content, what I'm making. If you like it, please consider subscribing. Most of my viewers are non-subscribers. Guys, it doesn't cost anything. If you subscribe my channel, it will help me to grow the channel. Please press the like button and the notification button so you can be informed when I have new videos. Thank you for watching. Thank you all that helped my channel to reach where I am now. I never thought that we'll have 1,500 users, not users, sorry, users from my work here, subscribers. Thanks very much. It's a very hot day. Stay safe, be careful, drink a lot, and see you next time, guys. Bye. Cheers.